When we think of trains, we often imagine the powerful steam locomotives. We see the long lines of carriages stretching into the distance. We hear the familiar clatter of wheels on the track, but there is a crucial detail that is almost always overlooked. This detail is the distance between the wheels on a single axle. It is known as the track gauge or the wheelbase. This simple measurement is the foundation of the entire railway system. It determines how trains stay on the tracks and how they travel across vast networks. It is a measurement that has, surprisingly, remained almost the same for centuries. This seemingly minor detail is incredibly important for the smooth operation of railways. If the wheels are too close together, the railcar can become unstable. It might wobble or even tip over, especially at higher speeds. If the wheels are too far apart, they will not fit on the standard tracks. This would make it impossible for a train to travel from one line to another. The exact distance was a critical decision made by the very first railway pioneers. Their choice has had a lasting impact on how we build and use trains even today, on this day, June 9th, 2025. The consistency of this measurement is a marvel of engineering foresight. Imagine trying to build a new road system where every car had a different width. It would be chaos. The railways avoided this problem from the very beginning. By settling on a standard gauge early on, engineers ensured that any railcar could, in theory, travel on any track. This idea of interoperability was revolutionary. It allowed for the creation of massive interconnected networks that could span entire countries and continents. The simple act of agreeing on a number became the key to unlocking the potential of the railway. So why has this specific dimension stood the test of time? The answer lies in a combination of historical accident, practical benefits, and the sheer difficulty of changing such a fundamental standard. Once thousands of miles of track have been laid and thousands of railcars have been built, altering the gauge becomes a monumental task. It is expensive, disruptive, and offers few advantages over the existing perfectly functional system. The story of the railway wheelbase is a story of how a good idea, established early, can become a permanent and powerful standard for generations to come. The story of the standard railway gauge does not begin with steam engines. It begins much earlier with horse-drawn carts and ancient Roman roads. The first railways were not for passengers but for hauling coal from mines. These early wagonways used wooden rails. The carts that ran on them were simple, pulled by horses. The men who built these carts did not invent a new width for them. They simply built them to the same dimensions as the carts they already used on the local roads. This was a practical decision, not a scientific one. It was easier to use what was already common. These local roads, particularly in the north of England where the first railways were born, had a long history. Many of them followed the paths of old Roman roads built centuries before. Roman chariots had a standard wheel spacing. This spacing created ruts in the roads over time. To avoid breaking their wheels, later cart makers built their carts to fit neatly into these existing ruts. This Roman standard, passed down through centuries of cart-making tradition, was about 4 feet and 8.5 inches. It was this very measurement that George Stephenson, the father of the modern railway, adopted for his pioneering locomotive, the Rocket. Stephenson was a practical man. He was building the Stockton and Darlington Railway, and later the Liverpool and Manchester Railway. He needed to choose a gauge for his tracks. He saw no reason to invent a new one. The coal carts at the Killingworth Colliery, where he worked, already used the 4-foot 8.5-inch gauge, so he simply adopted it. He was not thinking about creating a global standard. He was thinking about what would work for his specific project. He was using a dimension that was proven, reliable, and readily available in the workshops around him. This choice, born from convenience and historical accident, quickly became the standard. As Stephenson's railways proved to be a massive success, other engineers copied his designs. When they built new railway lines, it was easiest to make them compatible with Stephenson's. This allowed trains and carriages to move from one line to another without interruption. What started as the width of a Roman war chariot, passed through the hands of medieval cartwrights, was now being laid down in steel across the globe. The age of the railway had begun, all built upon an ancient, accidental measurement. Keeping the same wheelbase across an entire network provided enormous practical benefits. The most important benefit was interoperability. This meant that a railcar built in one city could travel on tracks in another city hundreds of miles away. This was a revolutionary concept. It allowed for the seamless movement of goods and people across a country. A factory could load its products onto a train, and that same train could deliver them directly to a distant market. There was no need to unload and reload cargo onto different trains, which would have been slow, expensive, and inefficient. This consistency also made manufacturing and maintenance much simpler. Factories could mass-produce wheels, axles, and entire rail cars to a single standard specification. This lowered costs and improved the quality of the components. If a wheel on a carriage broke down in a remote location, a standard replacement part could be easily sourced and fitted. Railway companies did not need to keep a huge variety of parts for different types of trains. This standardization was a key factor in the rapid and profitable expansion of the railway system throughout the 19th century. Safety was another critical advantage of the standard gauge. Engineers and designers could focus their efforts on perfecting a single design. They learned over many years how to build trains that were stable and secure on a 4-foot, 8.5-inch gauge. They understood the physics of how a train behaved on this specific width of track. They could calculate the safest speeds for curves and the best way to design suspension systems. If there had been many different gauges in use, this process of learning and refinement would have been much slower and more fragmented, likely leading to more accidents. Furthermore, the standard gauge created a unified market for railway technology. Inventors and engineers knew the exact parameters they were designing for. This encouraged innovation. Companies competed to build faster locomotives, more comfortable carriages, and more efficient wagons, all designed to run on the same tracks. This competition drove progress forward at a remarkable pace. The entire industry could collaborate and build upon a common foundation, rather than wasting energy debating the fundamental width of the tracks. The simple, consistent wheelbase was the solid ground upon which the entire railway empire was built. The decision to stick with one wheelbase is a prime example of clever, practical engineering. It shows that sometimes the best solution is not the most technologically advanced one, but the one that everyone can agree on. The original choice of gauge might have been an accident of history, but the refusal to change it was a deliberate and wise decision. The railway pioneers understood that the value of a network is directly related to its size and connectivity. A single, unbroken network is far more powerful than many small, disconnected ones. The standard gauge was the key to creating that network. This legacy of consistency continues to shape our world. While there are other gauges in use in different parts of the world, Stephenson's standard gauge remains the most common. It allows for international train travel, such as the high-speed trains that connect cities across Europe. The Channel Tunnel, which links Britain and France, was built to the standard gauge, allowing seamless travel between the two countries. This is a direct result of a decision made nearly 200 years ago. It demonstrates the incredible long-term thinking that went into the foundation of our transport infrastructure. The story of the railcar wheelbase teaches us an important lesson about technology. It is not always about finding the perfect technical answer. Often, it is about finding a solution that works well enough and that everyone can adopt. This principle is called network effect. The more people who use a standard, the more valuable that standard becomes for everyone. The railway gauge is one of the earliest and most powerful examples of this idea in action. Changing the standard would provide very little benefit, but would cost an astronomical amount of money and cause immense disruption. In conclusion, the unchanging design of the railcar wheelbase is not a sign of a lack of innovation. On the contrary, it is a testament to the genius of the original concept. It was a design that was good enough to start with, practical enough to expand, and so effective that it created a system too valuable to change. From the ruts of Roman roads to the high-speed lines of the 21st century, this simple measurement has provided a reliable and efficient foundation for one of the most important inventions in human history. It is a quiet, unseen, but brilliant piece of engineering.